we're trying to calculate the surface area of this parabolic cylinder across the region of this triangle. We're going to have to draw this out in order to understand what this means, so let's go and do that. Well, we're given the triangle as the vertex the vertices 0, 0, 0, 4, and 4, 4. And this is supposed to be in the xy plane, which is going to be just flat ground. So we'll start with 0, 0, and then we go to 0, 4, that's 0, and here's 4. And then there's a 4, 4 as well, so it'll be something like over here. So we can kind of see the triangle that way they're looking at. And the parabolic cylinder is basically just going to be like this like long cylinder like this, because it's going to have infinite x. So you can kind of just see this as, once here is going to be all zeros, right? But as you start to increase the y's, it's going to curl upward. And so you're going to kind of get this wall showing up here. It looks something like this. And it should kind of curl up as you get towards here as well. So I'll try to erase the center, make it slightly clearer. Here's the area we're kind of looking at. And put this back here a little bit. You can see how it looks 3D wise. But basically this is going to be from 0. And then here we're going to hit the 4s are the maxes on the y. And it's also the max on the x's too. Keep that in mind, kind of. And then from here, you could start setting up the equation that we know for surface area. It's not too bad. It's just ds equals the square root of fx squared plus fy squared plus 1 dx dy. And if we want to take the fx of this formula here, fx is going to be 0. There's no x's. Fy is going to be 2y. And now we can try to set up the integral. So we're going to need a double integral here, dx and dy. Y is on the outsides, so for y, we'll go, I guess it's just going to be 0 to 4 for the y. And then for the x's, we'll have to use the formula of some sort. Let's see. Well, we probably should get it from drawing like drawing something. If we're going to want to integrate over y's at the end, that means we want lines going across. And if we just draw a random line over here, we could see that it's going to be intercepted by this. So it's not going to go all the way to 4 for the x's. It's going to stop at this line. That line is actually the line, this is 0, 0, and this is 4, 4. So the line is y equals x that it's stopping at. And that's actually going to be true no matter where we are here. It's always just going to encounter that line. So that's going to be that line there. 0, and then the final x position is y. So the y and the x's match. Okay, so we have the limits there, and we're going to set up the formula. So it's just going to be square root of, well, 2y squared is 4y squared plus 1. And it's dx dy. And this is actually easy integral because it's over dx. So all we got to do is just put x square root of 4y squared plus 1. We're going from 0 to y, so that turns into a y. 4y squared plus 1. Now we're going to integrate over the y's, and this is an easy integral. Let's start with rewriting this by 4y squared plus 1 to the 1/2. Then we're going to add 1, and then we're going to divide that by the denominator, which we're going to use the reciprocal. So 2 over 3. And then we're going to multiply it by the derivative of the inside, which is 8y. And then we'll cancel these out. This will be left with 4. So the final answer is going to be 1 over 12. And then 4y squared plus 1, 3 over 2. This is going from 0 to 4. Let's go ahead and put that out. 4 squared. 16 times 4 is going to be 64, plus 1 makes 65. 3 over 2. And then there's going to be like a 1/12 on the outside. But we're also going to subtract when we put 0 in there. That's just going to be 1. And then it's also divided by the 12 at the end. So there we go. That wasn't too bad.